how to do identification disclosure and how to evaluate the risk. So you read the paper or the part of the paper that I asked you to do. So you know that there are 3 general summaries. Okay? The expected match risk, the true match rate, and then the false match rate. And what we're trying to do is, well, each of this summary, I think, is summarizing one aspect of the identification disclosure risks. Okay? Like if you can tell from the name, I mean, we're going to look at the definition of each of those soon. But I just want to mention that each of them is looking at one particular aspect. And for your project or for any kind of application, some of the measures might be more important to take care of or like to worry about. Like say, for example, for some project, you might want to make sure that the true match rate is really low. In a sense that, well, that might be your gold standard of comparing different synthetic data sets. Okay? So keep that in mind. All right, so to introduce those 3, we have to have some definition and notations. Okay? So CI, you read the paper, you know, is the number of records with the highest match probability for the target record I. Okay, so for record I, we count the number of records in the synthetic data that will have the highest match probability. Okay, so what we mean by that, I think I wrote it on the to-do list for this week. That think about, say, the number of records with the highest match probability. If we're working with categorical data, let's just say I know somebody's sex, race, and marital status, right? So I use that, and then I look at how many records in my synthetic data sharing the same pattern or the same combination. Let's just say there are 10 people matching exactly the 3 variables I'm looking at, then my CI is 10.
Yeah, and that's the problem I encountered. If your CI is 10 and T is mostly likely like 1 or 0, then when we're doing the true or false match risk, it asks us to do like C times T equals to 0. And that's just like not really good.
Yeah, all right, so I will get to that. Yeah, so good point. So I think for now, let's just get across that CI will be the number of records sharing the same combination, okay? So I showed it here that, so the combination is what we assume to be known by the intruder, right? So that's, again, it's based on intruder knowledge and behavior. And bullet point 2 here, I talked about categorical variables, but then you should start brainstorming, especially for those of you who are doing synthesis for continuous variable. Like for categorical variable, we can talk about like a combination pretty easily, right? Like everybody sharing the same. But what about for continuous variable if you have synthesized them? Okay, so that will be something you can consider. For example, if I'm looking at income, for an example like the income. So maybe in addition to the pattern or to the combination that we have, like sex, gender, or sex, race, and marital status. So you first of all like count how many observations are sharing the same combination, right? But then you also should worry about or should take care of the continuous synthetic variable and the true variable or true value that you have together in order to count how many CI you have. So I'm gonna keep the demo and also discussion about the categorical for now, just to make life easier. But keep in mind that for continuous variable, you still need to do some work for it, and then there's no fixed way of how to do this. But I think as we go along, it will become a little bit more clear, hopefully. All right, so CI is the number of records, like say sharing the same combination for categorical data. And then we define this TI if the true match is among the CI units, and it's going to be 1. If that is true, it's going to be 0 otherwise. Okay. So in this case, say for example, we found 10 records. Okay, we found 10 records, and then we are trying to figure out, okay, like among the 10 records, whether the true one is among them or not. Okay, if it is among them, we label TI to be 1. If it's not among them, we label TI to be 0. Okay? So that's what it is. Okay, like you might be wondering why you can have a 0 for TI or like a 1 for TI. So the thing is, you have a record, and the record, like my target record, you have a record there, And you will have it, let's just say, it could be not among the top matched rate. Let me say it again. So for this record, for my particular record I noticed that the CI is 10. Okay? I noticed that in the synthetic data, there are 10 records sharing the same combination. Okay? But the record that I'm working with, because we are the holder of the confidential data, we also know whether we can check whether the record that I'm working with is actually among the 10 that we have matched. Because you're counting the CI in the synthetic data, not on the real data. Okay? So on the synthetic data, it's possible that, well, my record, say like, so for example, anyway, so it's possible that the matched record is actually not among, sorry, the true record is not among the matched records, then that will reduce your TI to be 0, okay? But it's possible that it's among them, then TI is 1. Okay, so in practice, we're gonna see that a little bit more clearly. Okay? All right, so this is the case I think Maggie was asking earlier, so let me just go over them and then we can look at how to do it in practice. So notice that we have other measures that we care about, like the true match rate and the false match rate. So the true match rate is based on this KI. So look at what KI is. So KI is 1 if the true match is the unique match. Okay? So what we mean by that, so I put this in the parentheses of how to compute KI. That's what it is. And what we mean by KI equals to 1 is if CI times TI is 1. What we mean by that is, so TI can be either 0 or 1, right? And CI could be, well, from 0 to the number of observations you have, okay? Because CI is the number of observations that can match, right? So KI only equals to 1. If CI equals to 1, then TI equals to 1. And that's what we mean by the true match, which is TI is 1, is the unique match. Let me go over that again. So CI, so if you look at this, KI, if KI wants to be 1, not wants to, if we want KI to be 1, then it has to be CI equals to 1, and then TI also equals to 1. Okay? Because otherwise I cannot get my KI equals to 1. So what that means is my TI has to be 1, meaning that my true record is among the matched record, right? But also the matched record is only 1 record. So that's what we mean by it is a unique match. The true match is a unique match, okay? Otherwise, KI will be 0. Okay? The reason why we do that is because we want to see that, well, how many records will be uniquely matched correctly? Because that's looking at one aspect of the identification disclosure. Make sense? Make sense? All right. And then we also think about the false match. And what the false match is going to show you soon is that, well, there might be many records are uniquely matched, but the unique match might not be the true match. So in some way, we want this Fi to be as large as we can. Okay, so first of all, let's see how we define Fi. So Fi equals to 1 if Ci times 1 minus Ti equals to 1. So what does that mean? Ci will have to be 1, right? And then 1 minus Ti will have to be 1 as well. You only have 1 times 1 equals to 1, okay? So when Ci equals to 1, we know that there is a unique match, okay? Well, 1 minus Ti equals to 1, that means Ti has to equal 0, right? Meaning that for this record I, there is only 1 match, but that unique match is not the true match. I think it's a little bit like just the wording and all, it's a little bit complicated, but that's what we're trying to get. Okay, so think this through, and then otherwise Fi equals to 0. Okay? So this is going to give us a sense of, well, even though you can have many unique matches, that's not good, because unique matches usually gives us a sense that many records are very unique, right? But then the unique match might not be the true match anyway. So we want to get a sense of, well, you can have like 100 unique matches, but maybe only 1 of them is correctly matched. The other 99 is, well, the intruder might be really happy because that's the only one the intruder will find when Ci equals to 1, right? but the identity that the intruder will get is actually wrong. That's what we need. Okay. And lastly, two more quantities we need to know. N, capital N, is the total number of target records. So typically we do this identification disclosure evaluation for all of the records. So capital N will just be equals to little n. Okay. So this is just a notation. I mean, because you can maybe only think about half of the records as target. So n, capital N could be 1 over n. Sorry, 1 half, 1 over 2 times n. Okay. But typically we do that for all of them, so that would be fine. We have one more item here, which is the small s. That is the number of uniquely matched records. So that is, you count how many, yeah, I should put parentheses over here. You're looking at how many CI equals to 1 out there. So again, CI is the number of records that share the same combination for record I. Okay, so when CI is 1, it is a unique match. Okay, we're counting how many unique matches are there. All right, so let's live with that. All of them hopefully make sense. And now we're ready to define the 3 different summaries. The first one is the expected match risk. And you see that we're looking at TI over CI, and then sum them up for the entire data set. So you can think of it as how likely, on average, how likely it is to find the correct match for each record. Okay? Because what is TI? TI is either 1 or 0, right? And CI is what? CI is either 0 to, I don't know, n, maybe. Because CI is the number of records will have the same combination, okay? So this ratio, TI over CI, gives you the sense. So when TI equals to 1, what does it mean? When TI equals to 1, this means that the true match is among the CI matches, right? So let's say I have 10 records here, share the same combination, okay? And in fact, my TI is 1 as well. So for the intruder will just randomly guess which one of the 10 is the actual person, right? So this ratio gives us a sense of, on average, how likely is a probability. On average, how likely it is for the intruder to guess correctly which person is among the CI records. When TI equals to 0, well, the whole term is going to be 0, meaning that, well, even if your CI is really small, like you only have 2 records with the matched combination, but your true match is not among them, so there's no chance the intruder will be able to guess which person. He can still guess, but it won't. There's no chance for the person to guess correctly because my true match is not among them. Okay, so that's how you can think of this ratio, and we do that for every record, as you can see over here, and then sum them up. Okay. One caveat in terms of computing is that, well, what if you have CI equals to 0? Like there's no records to be matched at all. And in that case, we just set the ratio to be 0. Yes?
If you have multiple CIs that are all the same to the target, then do you only count it as 1, or do you count it as many as?
What do you mean?
Like if you have like 5 entries and they're all the same, so they all match, like the probability of them guessing the records is like 1.
Oh, I see what you mean. Yeah. So in this way, so we define expected match risk in this case, say, like you say, your CI is 5, right? You have 5 of them. And if your true match is among them, then we assume that the intruder will just randomly guess 1 out of 5. So that's why we take the ratio of 1 over 5 instead of 1. So what you're getting, which is an interesting point, because, well, if you match, like you find 5 records to be the same, then in that sense, in some sense that if you're thinking about attribute disclosure, like guessing, like maybe another synthetic variable like the person has, then if you have 5 of them, then you're probably just going to have a higher chance of guessing that particular value, right? But in terms of identity, it's more about 1 over how many you have. Yeah. Make sense? Make sense? Yeah. So in that case, each TI over CI is the record level probability between 0 and 1. Okay. But when you sum them up, then you can think of it as a sample level summary of the expected risk for the entire file. And overall, the higher the expected match risk, the higher the risks for the file itself. and vice versa. So that's what we should take away about this expected match risk. Okay? All right, so the true match rate, as you can see, is Ki over N. So Ki, we know if it's a true unique match, then Ki is 1, right? Because that's where Ci times Ti is 1. And then N, we know capital N is the number of targets that we're thinking about, so typically it's small n. So when you take the ratio and then take the sum, it's going to give us the percentage of true unique matches in the data set. Okay, so again, I think overall intuitive, and then we so if this true match rate is, the higher it is, the higher the risks overall. Make sense? Make sense? All right, the last one is the false match rate. That is when we're thinking about, okay, Fi, we know that's going to be a false unique match equals to 1, and Fi will be 0 if it's not. And small s, earlier we defined it to be the number of records who are unique matches. So that's counting how many i's or how many records are out there with Ci equals to 1. Okay. So when we do that, we'll be able to get a percentage of how many records we have here that even though they're unique, but they're not the right match. It's a little bit convoluted here. We're looking at S as the number of unique matches, but Fi as the indicator, binary indicator, it is 1 if it's if it is a non-true match. Okay, if it is 0 if it's a true match. So in this case, we actually want this to be as high as possible, because the higher the false match rate, the lower the risk. Make sense? Make sense? Yeah. Well, again, I think once we put everything into practice and then doing it, I think it will become a little bit clearer of why we're doing all of that. But it's still important to get through the definition over here. And just a quick summary. If you have higher expected match risk, or higher true match rate, or lower false match rate, they're all going to indicate higher identification disclosure for the sample. Okay, and you might be wondering, okay, if I'm doing multiple synthetic data sets, what can I do? So just like what we did with the interval overlap utility measure earlier, you do all of the expected match risk, true match rate, and false match rate. You do that for each synthetic data set, and then average across the different synthetic data sets to get a summary. So that's what people usually do. And all right, I'm just gonna